Good morning, students. On today's lecture, I'll solve Additional Mathematics Paper 1 of 4037, Variation 11, May, June 2018. In my first question, I have solved the equations. I have two equations given, pair of equations. That means a simultaneous equation. So first one is a linear equation and the second one is non-linear. So what I'm going to do, I'm going to take the linear equations and make y is the subject, because then I'm going to have y positive and x positive on this side. So that's that. And in this equation, the nonlinear equation, x squared plus y squared minus 8x minus 4y minus 16 equal to 0. What I'm going to do, see that y equal to x plus 4. In the place of y, I'll replace with this value over here. So x squared plus, in the place of y, I'm going to put x plus 4 square, then minus 8x minus 4, and this y is going to be x plus 4 minus 16 equal to 0. Okay, taking the bracket off of this equation. So x squared plus, this is in the form of a plus b whole square. That means a squared plus 2ab plus b squared. So a squared means x squared here, and 2ab means 2 times x times 4. That means 2 4s are 8x, and b squared means 4 squared. That means 16 minus 8x, taking this bracket up, minus 4x minus 16 equal to 0. Now if you look closely, these two are like terms, so I can add them to x squared. Now this is 8x, and see that this is 8x, so I can cancel this 2 out, positive 8x and negative 8x. Now I'm having minus 4x, and this 16 cross out. So I'm gonna have this minus 16. Okay, so minus 16 equal to 0. Now over here, if you look closely, all these three terms, their coefficients are multiple of 2. So you have to have this mathematician I to take this common. It will make your calculation a lot easier. Okay, so when is that, transpose this to the other side, 2x minus 8, so it's going to be 0 by 2. That becomes 0. Okay, so you can use the middle term break for that one. X squared minus 4x plus 2x minus 8 equal to 0. Taking x common from here, x minus 4, and from here taking 2 common, x minus 4 equal to 0. Now from these two terms, I can take x minus 4 common, x minus 4, then I'm going to end up with x plus 2 equal to 0. Therefore, either x minus 4 equal to 0 or x plus 2 equal to 0. This gives me x equal to 4, and this gives me x equal to minus 2. Now when I put this value over here, when x equal to 4, I have y equal to 4 plus 4 equal to 8. Let me write down the answer here. So answer, x and y, when x equal to 4, y equal to 8. And there is another value. And when x equal to minus 2, y equal to y equal to minus 2 plus 4, that gives me 2. So that's another answer is x equal to minus 2, y equal to 2. So that's my final answer. Okay. Now question number 2, it says that find the equation of the perpendicular bisector. Now this is a very important phrase, perpendicular bisector. You need to understand what is perpendicular bisector. If we have this line, okay, perpendicular bisector means there is a point which equally bisect this. That means equally it divide this to this 2 points. Okay, actually the length line segment. Okay, if you join this, let's say there is the point A and there is this point B, and bisector, there must be a point in the middle of this AB which actually exactly in between of A and B, in the middle of that. So this and this has to be equal, and most of the time we call it M for midpoint. And perpendicular means on this bisector, we supposed to have a line which this line is perpendicular on this one. That means this line makes 90-degree. Okay. Now, in this math, you don't have to be politically correct. There are 2 points, 1, 3, and 4 minus 5. So you can put either way. This is going to be 1, 3, and this is going to be 4 minus 5. What do I mean by politically correct is if you are drawing the Cartesian plane like that, so 1, 3 should be somewhere over here, and this is going to be somewhere over here. So the point is supposed to be like, the line is going to be like this. But I don't need to be that politically correct. That should do it. Now M, the midpoints formula is average of the x coordinates. That means x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So this M is going to be, let me write down this M over here. So M is going to be 1 plus 4 divided by 2 and 3 minus 5 divided by 2. So I'm having M 5 by 2 and 3 minus 5 is minus 2 divided by 2 minus 1. So this point over here is 5 by 2 minus 1. All right, pretty good. What about the gradient of this AB? Okay, gradient's formula is difference in y-axis over difference in x-axis. Okay, now this gradient of AB is gonna be minus 5 minus 3 over 4 minus 1. So that's gonna be minus 8 by 3. Now this gradient and this gradient, okay, which is perpendicular, okay, when it's perpendicular, this gradient and this gradient, their product has to be -1. That's the formula. Gradient 1 times gradient 2. If they are, if L1 is perpendicular to L2, if, then this is true. Gradient of L1, gradient of L2, their product is -1. Okay, so that's another formula you need to know. So I have this gradient AB right over here. So gradient of the perpendicular would be this one minus 1, and if I take this one to that side, it's going to be gradient of AB. So that's minus 1, and over here minus 8 by 3, minus minus cross out, so 3 goes on the top and 8 at the bottom. So that's that. Now when you have a point and gradient is 3 by 8, when you have a point and a gradient, the equation, the formula of the equation is such, this one, y minus y1 equal to m x minus x1. Okay, so over here y is like this, and y1 you have minus 1, so that's minus 1 equal to gradient is 3 by 8, and over here x is minus 5 by 2. Okay, if you take that bracket off, take this 8 to this side, so this is going to be y minus minus plus 1, and bring this 8 over here. So that's going to be 3x minus this 315 divided by 2. We can do some more calculation, 8y plus 8, and that's going to be 2, 3 to the 6x minus 15. Bring this to that side. Bring this to that side. So 8 to the 16y plus 8 to the 16 equal to 6x minus 15. Now watch this. I have to put this in this equation in this format, ax plus by plus c. That's very important. We have to put it in that format. So 6x, bring this one to that side, minus 16y, then minus 15 and minus 16, that's minus 31 equal to 0. So that's my equation done. Okay. Okay, question number 3. Diagram A to D, A, B, C, D show 4 different graphs. In each case, the whole graph is shown and the scales on the 2 axes are the same. So if this is 1 unit, this is 1 unit, this is 1 unit, this is 1 unit, so scale is same. Now it says place ticks in the boxes, so tick marks in the boxes in the table to indicate which descriptions, if any, apply to each graph. So these are the description, not a function, one function, a function that it is its own inverse, a function with no inverse. Okay, apply to each graph. If any, apply to each graph. This description applies in any one of this graph. There may be more than one tick in any row or column of the table. Okay, let's go for the function, not a function. Now we know that by the vertical test, okay, vertical line test, if I draw a vertical line on the graph, if that line intersect the graph in more than one point, that's not a function. Okay, look at this one. Okay, I can see that vertical line, if I draw it, it intersect this graph at 2 points. So this is not a function. So, and that is b. We can write down b is not a function. So that tick mark. Okay. Now one function. Now one function, you have to know that any values of x, there is only one value of y. Okay. Now over here, okay, if I go like that, okay, I can see that there are one value of y, but more than one value of x. So that's not it. But over here, see that x's value, if x's value is 1, there is only one unique value of y. X's value 1 and one value of y. Okay, and this one over here too, one value of x, one value of y. So c and d both are 1 and 1 function. Don't imagine that if it goes that way. Okay, this is not given, only this part is given. So in the given part, what is true, which description is true? So 1 function, c and d, c and d, these are true for 1 function description. This 2 graph fits in this description. Okay, now a function that is its own inverse. Okay, now which one is in its own inverse? Okay, now inverse, I hope you understand this one, or you know this. If you have a graph like this, if this is function of x, okay, and this is the line y equal to x. Now inverse function always has to be reflected on this line. So this one should be something like that, and that's gonna be inverse function. Okay, so whenever we are, I look at this one, if I look at this one, it's not reflected on y equal to x. You have to have some imagination power over here. Okay, now when I do that, it should be something like this, so not this one, but over here, if I draw this line, see that this reflect on this one. Okay, so this is actually the same thing. This reflects on this one, this reflect on this one. Okay, let me give you one more example. If you have something like this, okay, and you have something like this. Okay, so this reflected on this one, they are different line. Okay, this one is function of x and this is inverse function of x. Okay, they form 2 different line. But when this thing reflect on this one, this part coincide with this part and this part coincide with this part. So this graph is a function that is its own inverse. So that's gonna be c, this one. Okay, c. A function with no inverse. Now, usually, if you have many 1, what many 1? X's value many and y value like that. X's value many and y's value 1. This is a function. Okay, function. See that vertical line test? If I put this one vertical line test over here, all these 3 are function, right? But many 1 function, when you find out the inverse, then it becomes 1 many. Okay, 1 many. That means the one value of x becomes gives more value of y. Okay, this one we don't call inverse. We don't call it function. We call it relation. So all the many 1 function, that's 1 many relation. It doesn't have, many 1 function doesn't have any inverse unless its domain is restricted. Now this one, okay, see that if I take this value of y to be let's say 1, then I have 2 different value of x. Okay, so that's gonna be many value of x, x1, x2, only y value, 1 value of y, many 1 function. Now when I try to find out its inverse, then what it's gonna be? Now, if we try to find out inverse of this, it should be looking something like more or less like this. Okay, when it's more or less like this, let me do this, more or less like this. Now look at this. When I draw the vertical line like that, it intersects in two different points. So this is not a function. Okay, it doesn't have any inverse. Okay, the inverse is not a function, so it doesn't have any inverse. So we're gonna put tick mark over here, that not a function. That's gonna be A. Okay, it's not a, it's a function, but it doesn't have any inverse. Okay, so that's that. I hope you understand that. And then we're gonna go for question number 4. And question number 4 is saying that the curve y equal to a plus b sine cx has an amplitude of 4 and period equal to pi by 3. Okay, given that the curve passes through this point, find the value of each of the constant a, b, and c. Now y equal to b sine cx plus a. Okay, now b is the amplitude, so amplitude is 4, so b directly we can write down 4, and then period t equal to, that's gonna be 2 pi divided by b, and in this case b is c, so and period is given pi by 3, so pi by 3 equal to 2 pi, and in the place of b we're gonna put c, so c is gonna be here 2 pi, and then pi gonna come down here and 3 gonna go up there, so this cross out equal to 6, so c equal to 6. Okay, now next one is the y-intercept. Okay, to find out that, we need to replace this point over here. In the place of x we're gonna put this, and in the place of y we're gonna put that. So it's 2 equal to b, we already know 4, sine, c we know 6, and then x plus well, x's value is over here actually pi by 12, and then a. Okay, now this is gonna be 6 cross out 12 is 2, so it's gonna be 2 equal to 4 sine pi by 2 plus a. Now sine pi by 2, that's going to be 90 or 1. So 2 equal to 4 times 1 plus a. So a equal to 2 minus 4 is minus 2. So a is going to be minus 2. That's my answer. Okay, a equal to minus 2, b equal to 4, and c equal to 6. That. Done. Okay. Using your values, of a, b, and c, these values, sketch the graph, this one for 0 to pi radian. Okay, 0 to pi radian. Now usually our regular interval is pi by 2, but whenever we have c, then what happened, our regular interval is gonna be that regular interval divided by this c. In this case, c is actually this particular place over here is 6. Okay, so that's gonna be pi by 12. Okay, that's that, but we're gonna come to that one later on. In this is sine graph, so within 2 pi it's supposed to be one complete revolution. Okay, within 2 pi, but since there are where's that, this c is 6, so within 2 pi I supposed to have 6 cycles. Okay, or 6 oscillations. Now over here in this pi I supposed to have half of that, so 3, and that 3, see that if I take 2, that's one complete revolution, one complete revolution, one complete revolution over here. So I'm gonna just draw this over here a little line to help me out over here. So I'm gonna have one complete cycle here, one complete cycle here, one complete cycle here. Now I have to find out the baseline. Okay, let me rewrite this equation. Y equal to b is my 4, sine, c is 6x, and a is minus 2. I need to have that. Why? Because I need to have minus 2 over here, So minus 2, minus 4. So it's gonna be minus 2, minus 4. Here 2, 4 the way they have given. So that's minus 2 should be somewhere over here. That's minus 2. And I'm gonna write down y equal to minus 2. And then from here the highest gonna go 4. So 2, 4 right over here. So it start from here and then somewhere over here, somewhere over here, somewhere over here, somewhere over here. Now the graph's supposed to be this one. Okay, and then I'm gonna have some point over here, 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 and here. So it's going to be like this. If you don't understand what I'm doing, please watch my video how to draw this kind of graph. I have shown sine graph, cos graph, and tan graph, how to do that. Then whatever I'm doing here, it's gonna be really clear to you. Okay, so that's my graph of this one from 0 to pi. Okay, now question number 5. The population P of a certain bacterium T days after the start of an experiment is modeled by P equal to 800 e to the power kt. Okay, where k is a constant. State what the figure 800 represent in the experiment. So it's P equal to 800 e to the power kt. Now when t equal to 0, we got 800. Now 800 represent initial number of the bacteria. Okay, what does that mean? That when we started to count the time or keep the time, that time our bacteria's number was 800. Okay, so that's what it means. Given that the population is 20,000 2 days after the start of experiment. So this one was beginning of the experiment. Okay, beginning of the experiment. So 20,000 is number of the bacteria 2 days after the start of experiment. Calculate the value of k. Okay, fine. So P is given 20,000 equal to 800 e to the power, we don't know k, but t we know, this is 2. Now if I bring this 800 over here, 20,000 divided by 800, that's gonna be e 2k. Okay, this cross out, so 200 divided by 8 is 25. So 25 equal to e 2k. Now I can take ln on both sides. So ln on both sides. So ln 25 equal to ln e to the power 2k. Now this is ln 225 and 2k comes over here, and ln e nothing but 1. Therefore k equal to ln 25 by 2. Okay, now that's gonna give me ln 25 divided by 2. That gives me k equal to approximately equal to 1.61. Okay, so that's the value of k. Calculate the population 3 days after start of the experiment. So now P, that's the population. We need to find out 800. K we know 1.61 and 3 days after, so times 3. So what I'm gonna do, E, then I can put the answer I had 3, that times 800. So I got 100,000. So that's my final answer. Okay, thank you for watching. In my next video I'll continue from question number 6. Take care. Bye.